Good day, everyone. We are from Bmmv S11 Group 6. Okay, today we are going to present about the assignment given. Our assignment is about conduction graphical analysis on heat transfer. Okay. Before we start our presentation, I would like to introduce our team members. Okay, my name is Norma binti BADRULHISHAM as a first presenter. And the second presenter is ILHAM Nur bin NORAEDE. The third presenter is Muhammad Danish ADLI bin Muhammad NAZRUL. And our last presenter is Muhammad AZRUL HAKIM bin AHMAD. For today's agenda, this presentation will cover about the introduction and objective, the product design that we have created, the result based on the product design, and the discussion and conclusion. Okay, for introduction, this presentation will discuss about the different design of fin surface, two different design of fin surface, and the second one is to perform heat transfer simulation process based on the fin surface. Okay, as for the objective of this presentation, the first objective is to produce a student's creativity in shaping the fin surface according to their respective creativity and to compare two different forms of fin surface according to the appropriate simulation. Okay, for the next presentation, I will give to second presenter Ilham Nur.
Okay, thank you, Norma. So, my name is ILHAM Nur bin NORAEDE, matrix number B0920103883. So, I'm going to talk about the product design as we, based on the assignment sheet given, we basically need to design two design. So, first design is the heat sink. We designed the heat sink. As you can see, the design is basic and simple. So the area of the heat sink is the length is 40 millimeter, the width is 40 millimeter, and the height is 30 millimeter. And for the fin amount is about 13 fin. So as you can see, the heat sink at the figure, and so I attach the drawing of the heat sink too. So next design is turbo fin. So this design is quite difficult to create because of the top of the surface design itself. So the area of the design is the length is 40 millimeter and the width is 40 millimeter and the height is 21 millimeter and the fin amount is 8 fin. So as you can see, the design is quite difficult, and so I attached the drawing too for the better understanding of the design. So next, I will give to Danish Adli for the simulation.
Okay, thank you, Ilham Nur. So my name is Muhammad Danish Adli bin Muhammad Nazrul and my metric number is B092010113. And now I will continue to the result. Based on the simulation that we have done, for design 1, we get that the heat dissipate uniformly based on the color gradient on the figure that I attach here. So the bottom part, which is the red color part, is the highest temperature, which is we get 97 degrees Celsius. And the lowest temperature of this fin is 77.1 degrees Celsius, which is the blue part one. So next we move to design 2. So design 2 also dissipate heat uniformly, as you can see the color gradient on the figure that I attach here. But the difference is at the highest temperature and the lowest temperature. So if you can see here, the highest temperature of this turbofin is 134 degrees Celsius, which is higher than design 1. And the lowest temperature is 122 degrees Celsius, which is also higher from design 1. So that's all. Now I will pass to Azrul Hakim.
Thank you to Danish ADLI. Assalamualaikum warahmatullahi wabarakatuh. My name is MOHAMMAD AZRUL HAKIM AHMAD. So I will present 4-part discussion and conclusion. So as we have learned, conduction is the transfer of heat between substances that are in direct contact with each other. The better the conductor, the more rapidly heat will be transferred. Conduction occurs when a substance is heated, particles will gain more energy and vibrate more. These molecules then bump into nearby particles and transfer some of their energy to others. To choose a material for heat sink is largely dependent on one factor: thermal resistance. Thermal resistance is the ability of heat to flow from a component and into its surrounding. For example, the resistance from the component to its package, the package to the adhesive material, then the adhesive material to the heatsink, and lastly the heatsink to the air. It will give an overall thermal resistance and help to understand what material should be chosen and how big the heatsink should be. The effectiveness of a fin is defined as the ratio of heat transfer with a fin to the heat transfer without a fin. Heat transfer in the absence of a fin is by convection from the area, usually a very small area, occupied by the fin. Next, for the conclusion. So by this experiment, we have studied the conduction graphical analysis on heat transfer by two different designs, which is design 1 and design 2 with different amount of film. So by performing a test through a simulation, we can conclude that the design 1 has a lower temperature compared to design 2. It is because the design 1 has more amount of film that can rid off more heat. We also can increase the length and the surface area to get the lower temperature. Moreover, when the distance between the fins are small, the effectiveness for heat removal is great. Hence, the rate of heat transfer can be differentiated by using the different amount of fin. That's all from us. Thank you and Assalamualaikum.